polynomial review. So state the degree. The degree is the largest exponent. The leading coefficient is the number in front of the largest exponent. It leads the equation. And the constant term is the term that remains constant. And the only term that's going to remain constant is the term without a variable. So that when you fill in a number in for x, it'll change all the other terms, but it won't change the term without a variable. It will remain constant. So this is the term without a variable, a letter. So the degree of this function is actually cubic. It's degree 3. Because I know that these are out of order, they're not in descending order, but the largest exponent is actually the 3, not the 2, so don't fall for that. The leading coefficient is not 34, because that doesn't lead the equation. I know it's at the front, but it's not the number in front of the largest exponent. My leading coefficient is actually negative 25, because it's the number in front of the largest exponent. Therefore, it leads the equation. So if it makes it easier for you, I would rearrange the equation right off the bat and put them in descending order. So 25x cubed plus 34x squared plus 2x minus 39. And always note when doing a polynomial, are you missing a term? Because if you're missing a term and you go to do synthetic division, you're going to have to remember to put a 0 placeholder. Our constant term is the one that remains constant without a variable, and it's our back term, which is negative 39. So what does the degree tell us about the graph? The degree tells us what it looks like. So if it's degree 1, it's linear. So it could be increasing or it could be decreasing, but it's a straight line. If it's degree 2, it's a quadratic. So it could be concave up, could be concave down. Degree 3 is a cubic. It can make that S shape, that's a definite one with a max and a min, or it could do just that curve, which is actually not a max or a min, but a point of inflection. Degree 4 makes an M for math if it's negative, and a W for Wagner if it's positive. And then degree 5 makes that extra little S in there. Now, if you notice, degree 1, degree 3, and degree 5 are called odd functions, and their arrows are in opposite directions. So they're always going to be, unless it's a word problem, XER for range, YER for XER for domain, YER for range. Degree 2 and degree 4 are even degrees, and their arrows are always in the same direction. So your domain, if it's a word problem, is XER, but your range is going to be greater than or equal to the minimum, if it's a min, the absolute minimum, and less than or equal to if it's a max, the absolute maximum. So you'd have to find those points to get your range. What does the leading coefficient tell us about the graph? How the graph ends on the right. So it's not actually the number that matters, it's the sign. If it's a positive leading coefficient, it ends up on the right. And if it's a negative leading coefficient, it ends down on the right. Now what to keep in mind here is if it's an odd degree, it's going to end up on the right, therefore it's going to end down on the left because the arrows are in opposite directions. If it's an even degree, like a degree or 2 or 4, they both end up in the same direction. So if it's a positive leading coefficient, it ends up on the right, but that also means it ends up on the left. And if it's a negative leading coefficient, it ends down on the right, which also means it ends down on the left. So your leading coefficient is not only helpful for right, it's also helpful for left, depending on if it's an odd degree function or an even degree function. What does the constant tell us about the graph? The constant is the y-intercept. Now, remember that your equation can't have any brackets. It has to be completely expanded out. Now, why would that give us the y-intercept? Well, if we use a basic case like a linear function, so 3x plus 7, when you're finding the y-intercept, you're telling me x equals 0. So when I plug in x equals 0, every function that isn't a constant is going to actually go away. They're going to cancel. So that's why the constant is always a y-intercept. If I used a fancier one, like negative 3x cubed plus 2x squared minus 7x plus 4. Once again, I'm putting in x equals 0 to find the y-intercept. Well, every place where there's an x is going to become 0. Because when I place 0 in there, they all multiplied by 0 will cancel. And what's left behind? The constant. So that's why the constant is always the y-intercept. So we're looking at linear graphs, okay? We're going to look at two specifically different linear graphs, and we're going to state all these lovely things about it. The linear graph is also known as the degree one because its exponent, and the x, is 1. We've been doing these since grade 9 at least. So the leading coefficient, I can't tell you exactly what it is. In this case, I could because the leading coefficient is actually the slope, but I'm not looking for that right now. I'm just looking for the sign of the leading coefficient. So I guess I should say sign of leading coefficient. So for this graph, it ends down on the right. So the sign is negative. For this graph, it ends up on the right. So the sign is actually positive. Indirectly, they end on the left in the opposite direction because they're odd functions. The constant is really easy to figure out because the constant is a fancy word for y-intercept. So actually, these two next lines will be the exact same. The y-intercept is 0. So my constant is 0. I don't actually have a constant because it's 0. This one, my y-intercept is 2. So my constant is 2. The domain, because these aren't word problems and we don't have any restrictions on the domain like time being that it can't be negative or something like that, the domain in set notation is XER. And for every polynomial, it's actually XER unless it's a word problem. That's set notation. Interval notation, it's from negative infinity to positive infinity, round brackets because it's not equal to. The range is YER because the arrows are in opposite directions. Whoa, wrote that in the wrong spot. This is XER as well. Because it doesn't change whether it's increasing, or decreasing. The range is YER because arrows are in opposite directions. So for set notation, and for interval notation, it's negative infinity to positive infinity. You're never going to have to state both of them. I'm just showing you both so that you can actually do both depending on which form you're asked. This one, the possible number of x-intercepts is 1. At most, they can have 1. You can always have, at most, the number of x-intercepts that equals the degree. This is a degree 1, so at max, I'm going to have 1. And I'm for sure actually going to have 1 because the arrows are going in opposite directions, so they have to cross through the x-intercept at one point, for sure. What is the x-intercept? Well, in this graph, it's 0. It's the same as my y-intercept because it crosses through the origin at 0, 0. And for this one, it's negative 4. And I would write it as negative 4, 0, 0, 0. So the y-intercept here should be 0, 0, and 0, 2. It's nicer as a coordinate. So I seem to have doubled up my y-intercept. The possible number of y-intercepts in this case. So possible number of x-intercepts is 1, and it's 0, 0. This one is 1, and it's negative 4, 0. Y-intercepts, this one has 1 always, and 1. Every polynomial has at most one y-intercept because they're functions and they pass the vertical line test. And if you wanted to have more than one y-intercept, it would have to loop back through and therefore not be called a polynomial function, because if it looped back through, first off, it wouldn't be a polynomial, but it also wouldn't be a function. So that would be the only way I could get two y-intercepts, because it wouldn't pass the vertical line test. So for every polynomial function, there's actually only one y-intercept. Then we have quadratics, which are degree 2. So I still look at the right arms for my sign of my leading coefficient. It's up on the right, so this is the positive leading coefficient. This one's down on the right, should have arrows. It's a negative leading coefficient. The constant in the y-intercept, once again, still the same. The constant here is 0. The y-intercept is at 0, 0. Y-intercept means x equals 0, right? So you're always going to have that 0 in front. This one, the constant is 5. And my y-intercept is 0 and 5. The domain, because it's a polynomial and not a word problem, it's XER for set notation, or negative infinity, positive infinity. And same thing here. All polynomials, like I said, unless it's a word problem, are XER. The range is not YER because the arrows are not going in opposite directions. If arrows are going in opposite directions and it's an odd function, it's going to be YER. But for degree 2 and degree 4, which are even functions, you end up getting greater than or equal to or less than or equal to. Because this one has arrows going up, there's no graph down here. The lowest graph part I have is when y equals 0. So my entire graph is greater than or equal to y equals 0. So I'm going to say y such that y is greater than or equal to 0, YER. That's my set notation, and I need it all. Now, it's greater than or equal to 0. I have an equal to sign. So it's going from 0 to infinity, positive infinity. Round bracket because it can never equal infinity. Now this one, we're going to say that this is a 7. It's kind of hard to tell, but we're going to say it's 7. There's no graph above it. It's a maximum, so the highest it goes to is 7. So my range is going to be y such that y is less than or equal to 7, YER, or it's less than 7. So that means it's going this here, these little arrows mean negative infinity all the way to 7. So we always go from low to high. So negative infinity round bracket because we can't equal it, to 7 square bracket because it does equal 7. So possible number of x-intercepts. So for this one, I have one x-intercept. For this one, I have two x-intercepts. But keep in mind, you guys, that you could have with quadratics, with linear, you had to have for sure one, and you have one for sure, always. With quadratics, you could have two x-intercepts. You could have one if it runs tangent with the x-axis, so it just touches it and then comes right back down. You could have one x-intercept. Or you could have none because the arrows are going in complete opposite directions. It could be completely above the x-axis or completely below the x-axis. But we will always have one y-intercept for the same reason as before. It's a function. It can't cross through more than once. And eventually, because the graph is getting wider, it will eventually cross through the y, even if it doesn't look like it is. This particular graph has a minimum at y equals 0 when x equals 0. So the x just literally tells you where it exists to help you out, but it really mins out at y equals 0. That's the important part. This one has a max at 7. At y equals 7 when it looks like x equals 1. Then we have degree 3 cubic. These follow all the same rules as degree 1. I have a positive leading coefficient because it ends up on the right. I have negative leading coefficient because it ends down on the right. Once again, sine of. My constant is my y-intercept. So this one is at 0. So my y-intercept is at 0, 0, because x equals 0. This one, my constant is at 1, 1, and my x-intercept's at 0 and 1. My domain and range, because the arrows are going in opposite directions, is xer, yer. Same with all odd functions. Negative infinity, positive infinity. Same with my y's, my range. Number of x-intercepts I'm going to do at the bottom again. So with degree 1, I could have 1 x-intercept. I could have 2. Subtangent and bounces down. So 1 x-intercept. I could have 2 x-intercepts. I could have 3, where it just goes through. I can never have 0. I max out at the degree. So if the degree is 3, that's the most I can have. I can't have 0 because the arrows are going in opposite directions. At some point, they're going to cross through the x-axis. And once again, I have 1 x-intercept, or 1 y-intercept, sorry, always. For this particular graph above, I have a point of inflection. It just curves through. There's neither a max or a min. This right here is called the point of inflection. So this one has a point of inflection at 0, 0. This graph here has a minimum at negative 1, 0, and a maximum at 1, 2. So minimum at negative 1, 0, right here, and a maximum that's the highest at 1, 2. And then we have degree 4, which follow the exact same as degree 2. And degree 5 follow the exact same thing as degree 1 and 3. Degree 5 can have at maximum 5 x-intercepts. It can have 1, 2, 3, 4, or 5. But it has to have at least 1 because a degree 5 has arrows in opposite directions. So at some point, it's going to cross through the x-intercept. A degree 4 can actually have none. The entire graph can be above. So it could have none. It could have 1, 2, 3, 4. And they max out always at their degree. So the next thing we went through was remainder theorem. Remainder theorem states when a polynomial function p of x is divided by a binomial, x minus a, the remainder obtained is equal to the value of the polynomial when x equals a. So basically, if I take this and I solve for x, and I plug it in for all the x's, being p of a, I'll get the remainder. So using remainder theorem only gets you the remainder. It's also helpful if they give you the remainder and they give you the divisor and they're missing a value. So we're going to go through that. So here they just want us to determine the remainder. The instant they just want us to determine the remainder, we can use remainder theorem. If they want us to solve or factor, we have to use synthetic division. So this is our polynomial, 6x cubed minus 4x squared. This should be plus 8x plus 6 is a little typo. We always want to look if they're missing a term. This one is x cubed, x squared, x number, so I'm not missing a term. If I was missing a term with remainder theorem, I don't have to replace that term because 0 times anything is 0. But in synthetic division, I do need it for a placeholder. So if I was missing it, remainder theorem, I could leave it out. But synthetic division, I would have to keep it. So I have my is 6x cubed minus 4x squared plus 8x plus 6 is divided by 2x minus 1. So I need to solve for that first. 2x minus 1 equals 0. Add the 1. 2x equals 1. Divide by 2. X equals a half. So now I'm going to find p of a half. What does that mean? That's function notation. What's in this bracket goes in for x. That's what function notation stands for. So for the polynomial, I'm going to put a half in for every x. So I'm going to get 6 times a half cubed minus 4 times a half squared plus 8 times a half plus 6. So I'm going to get 6, I have to cube both of them, so 1 over 8, minus 4 times a quarter, plus 4, plus 6. When you multiply fractions, you multiply numerator times numerator, denominator times denominator. So here I'm going to get 6 over 8, and 6 over 8 reduces to 3 over 4. These 4's are going to cancel, so I'm going to get minus 1 plus 4 plus 6. When I put these ones together, I get 3/4 plus 9. So you need to get a common denominator, and so you're going to get 3 over 4. You're going to multiply 9 by 4 over 4. So you're going to get plus 36 over 4, which is actually 39 over 4, which is actually equal to 9.75. So either one would work, depending on what answer they want. So that's how you just get the remainder. The remainder is 9.75 or 39 over 4. I don't know anything else about this. I don't know the x-intercept. I don't know the factors, but I do know the remainder. So if I'm asked for just the remainder, I can use remainder theorem. Another reason why remainder theorem is helpful is if in the polynomial here, like this one, I'm missing an a value and they give me a remainder and they give me a divisor, I can use remainder theorem to solve for a. So this one says, determine the value of a. If the remainder equals 131, the polynomial is that, and it's divided by x minus 3. So if it's divided by x minus 3, I said it equals to 0 and solve, I get x equals 3. So I know that if I go p of 3, and I fill that in from the previous example, like when I filled in p of half, I get the remainder. So when I fill in p of 3, it equals the remainder. I know that. But wait a second, they gave me the remainder. So now I know if I fill in p of 3, it should equal 131. And what does p of 3 stand for? It stands for fill in 3 for every x, which is function notation. So we're going to do that here. So I'm going to get 2 times 3 to the 4 minus 3 cubed. Oops. I'm going to put an equal between them. Minus 3 cubed minus a times 3 plus 8, and it equals 131. 3 to the 4 is 81, times 2 is 162. 3 cubed is 27, minus 3a plus 8 equals 131. And now I'm back to just plain old math from before. I only have one variable. So I'm going to put this side together. 162 minus 27 plus 8, and I get negative 3a plus 143 equals 131. Try and get a by itself, so the negative 3a. So I'm going to subtract 143, and I get negative 12. And then I'm going to divide by negative 3, and a equals 4. What's great about this is you can plug the a back into the polynomial. So you could make this be a 4, and then do remainder theorem with filling in the 3, and your answer should be, if you fill 3 in for all of those with the 4 in for a, your answer should be 131. So you can check it. This next one was the big long one that we did. Instead of missing one variable, so we did remainder theorem once. If we're missing 2 variables, we have to do remainder theorem twice. So We're missing a d and a c. So 2x to the 4 plus dx cubed minus cx squared plus 5x minus 8. The remainder is negative 41 when divided by x plus 3. So what does that mean? That means p of negative 3, because I have to solve that x plus 3. X plus 3 equals 0. So x equals negative 3. So when I fill in negative 3, I should get the remainder of negative 41. So I set up my first equation. And then the next one, they gave us p of 2 equals 74, which was nice. So p of 2 just means the factor was actually x minus 2. I would get a remainder of 74. So they could have wrote it that way, and it would be the same thing. Now, we're missing two variables, so we have to do remainder theorem twice. So I'm going to do it once over here, and I'm going to get 2 times negative 3 to the 4 plus d times negative 3 cubed minus c times negative 3 squared plus 5 times negative 3 minus 8, and it's going to equal negative 41. So negative 3 to the 4 times 2 is 162. And then we get negative plus a negative 27d, which you don't have to put the plus and negative. That's silly, but I just did it to prove a point. And then you're going to do negative 3 squared is positive 9 times a negative c is negative 9c minus 15 minus 8 equals negative 41. And then you're going to get the c and d on one side and everything else on the other. So 162 minus 15 minus 8, and we get 139. So we get 27d minus 9c minus or plus 139 equals negative 41, and then we're going to subtract that 139 from both sides. And we get negative 27d minus 9c equals 180, negative 180. And I box that because I'm going to need that to do elimination with in a second. I'm going to go over and do p of 2. So p of 2, I'm going to get 2 times 2 to the 4 plus d times 2 cubed minus c times 2 squared plus 5 times 2 minus 8 equals 74. 2 to the 4 times 2 is 32 plus 8d minus 4c plus 10 minus 8 equals 74. 32 plus 10 minus 8 is 34. So I get 8d minus 4c plus 34 equals 74. Subtract 34. And I get 8d minus 4c equals 40. And I box it. So we line them up. Negative 27d minus 9c equals negative 180. And 8d minus 4c equals 40. So now we want to do elimination. In order to eliminate, we need to make either the d's or the c's the same. I'm going to make the c's the same, and I want to make them different signs so that I can add. So I'm going to multiply the top by negative 4 to make it be a positive 36. And I have to do it to the top left and the right. And I'm going to multiply the bottom by positive 9 so that it still says negative 36 on the bottom, so that I can just add them and the d's will go, or sorry, the c's will go away. So I have 4 times negative 27, which is 108d, negative 4 times negative 9, which is positive 36c, and negative 180 times 4, which is 720. And then I have 9 times 8d, which is 72d, minus 36c equals 40 times 9, which is 360. And now, because they're opposite signs, I can add them. If they were the same sign, I would have to subtract and watch myself when I'm subtracting to not make oopsies with the negative signs. So when I add them, I get 180 plus d plus 72d, which is 180d. These cancel. And then 720 plus 360 is 1,080. Divide by 180. And d equals 6. Now that I know what d is, I can plug it back into either of the boxed equations. I'm going to plug it back into this one just because there's space below it. So I get 8 times 6 minus 4c equals 40. 8 times 6 is 48 minus 4c equals 40. And then I'm going to subtract 48 from 40. And I get negative 4c equals negative 8. Divide by negative 4. And c equals 2. And I could check this. I could plug the c and the d back into this polynomial up here. So I could plug 6 in for d and 2 in for c. And then I should be able to plug in either negative 3 and get for all the x's and get negative 41, or plug in 2 for all the x's and get 74. So I can check these. Okay, so lots of work, but that's how you do it. So if you're missing 2 variables, you have to do remainder theorem twice. If you're missing 1 variable, remainder theorem once. Okay, then we have factor theorem. So factor theorem states that the binomial x minus a is a factor of the polynomial if and only if p of a equals 0. What the heck does that mean? P of a equals 0? When you fill in p of a, remember it equals the remainder. So I told you guys this over and over and over and over and over and over again. If you read is a factor anywhere in your tests, is a factor screams remainder 0. It's the way that they tell you, and I tell you, that the remainder is 0, because if something is a factor, the remainder is 0. So they're not going to say when you divide by x minus a, the remainder is 0. They're going to say when divided by, or they're just going to say that x minus a is a factor, which means the remainder is 0. And you need to know that. You need to know that when you see is a remainder, you think, or sorry, when you see is a factor, you should think remainder is 0. It should be the first thing you think of. Okay? So they want us to show them then that x minus 4 is a factor. So what do they mean by is a factor? They want us to show us that when we plug in x equals 4, we get a remainder of 0. Right? That's what we want to prove, that we get a remainder of 0. Okay? So we only are caring about the remainder. If we only care about the remainder, we can do remainder theorem. So I'm going to fill in p of 4 and hope that when I fill 4 in for all the x's, I get 0, which means the remainder is 0, which means it is a factor. So let's try it out. So we're going to get 4 squared plus 2 times 4 minus 24. 4 squared is 16 plus 8 minus 24. And we get 24 minus 24, which is 0. So the remainder is 0. And if the remainder is 0, then we can say x minus 4, therefore, with these 3 little dots, therefore x minus 4 is a factor of p of x. Now for the next one, I just picked this one, not because it's really anything different than the last one. It's just that we need to fill in a fraction because we have to solve it out. So it is a factor. We have to prove it's a factor. Is a factor. We put remainder 0 so we don't forget what the heck that is telling us. So 2x minus 1 equals 0. We're not filling that in. We're filling in what x equals. So 2x equals 1 by adding the 1 over. Divide by 2. X equals a half. So when I fill in a half in for all the x's in the polynomial, 4x cubed minus 6x squared minus x plus 4, I'm hoping to get equal to 0, because then that means the remainder is 0, because I'm doing remainder theorem, which gives me the remainder. So we're going to do 4 times 1/2 cubed minus 16 times 1/2 squared minus a half plus 4. So we get equal to, We always want equal signs, or else we just have random expressions floating on a piece of paper, which mean nothing. We want to say that this expression equals the next one. 1/2 cubed is 1 cubed, which is 1, over 2 cubed, which is 8. And this is just 4 over 1. We multiply across top, across the bottom when we multiply fractions. Then we're going to get negative 16 over 1. And then 1/2 squared is 1 squared, which is 1, and 2 squared, which is 4. Minus 1/2 plus 4. So 4 over 8 reduces to 1/2. 16 over 4 reduces to 1/4. Minus 1/2 plus 4. Oh, 1/4. This is 4. Woohoo. Don't do fractions, yay. This is 16 over 4, which is 16 divided by 4, which is negative 4. Much better. So 1/2 minus 1/2, negative 4 plus 4, they cancel and I get 0. Yay. So 2, therefore, 3 little dots, 2x minus 1 is a factor of 4x cubed minus 16x squared minus x plus 4. Now this one is very similar to the A question we did in the past, but if you don't remember, is a factor means something, this question's going to be hard. So what is the question? Determine the value of A. So we're finding A just like we did before. When we're missing an A, we have to use remainder theorem. So that x plus 1 is a factor. Is a factor means the remainder is 0. They gave us the remainder. Most of you will sit and be like, I can't do this question. I don't know what the remainder is. We know the remainder is 0 because it says is a factor of x to the 4 plus 4x cubed plus ax squared plus 4x plus 1. So if we have x plus 1, we're finding p of negative 1, and we're setting it equal to 0 because we know it's a factor, so the remainder is 0. Okay, so we can do remainder theorem. So we're going to get negative 1 to the 4 plus 4 times negative 1 cubed plus a times negative 1 squared plus 4 times negative 1 plus 1, and we're set it equal to 0. Negative 1 to the 4 is positive 1. Negative 1 cubed is negative 1 times 4 is negative 4. Negative 1 squared is positive 1 times a is plus a. 4 times negative 1 is negative 4 plus 1 equals 0. And then we're going to get 1 and 1 and negative 4 and negative 4, which is going to be negative 8 plus 2, which is negative 6 plus a equals 0. Add my 6 over, and I get a equals 6. Factoring polynomials. Remember placeholders. Huge, 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 huge. Often people aren't bad at synthetic division. They just forget to put that placeholder in there. So if they're missing the x or the x squared, they forget to put the 0, and then you actually can't do it properly. Okay? So we're going to look at consider the polynomial p of x equals x to the 4 minus 2x cubed minus 9x squared plus 2x plus 8. And remember, factors are like x plus a, x minus 7, 2x plus 1. These are factors. They're called linear factors. Why are they called linear factors? Because each little factor makes an actual line. Each of these, like x minus 7, is actually a line. 2x plus 1 is a line with a y-intercept of 1 and a slope of 2. You could end up with, instead of linear factors, you could end up with a quadratic factor if it can't like factor. So say when you were doing synthetic division, you ended up with x squared plus 3x plus 1. You can't factor that. So that would be a quadratic factor because it would actually be a quadratic. But majority of the time you get linear factors. Okay, if I ask you to factor and you do get x squared plus 3x plus 1 or something like that, you can't put it into quadratic formula. The quadratic formula gets you x-intercepts. You would be done. X squared plus 3x plus 1 would be one of your factors. It would just be a degree 2 factor, not linear. Okay? Now let's go to this question. It says determine the potential zeros. We look at this back number 8 and we list all the factors of it. Those are the potential ones. So if you didn't have your calculator and you couldn't put it into your calculator and you couldn't look for x-intercepts off of your table, you would have to test these potential zeros to see which one gets you a remainder of 0. Therefore, you know it's a factor, and therefore you can actually use it to factor. Okay, so what are the potential zeros? Well, they are plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8, because those are the factors of 8. So we want this to be expressed in factored form. So we could try positive 1 first and see if it gets us a remainder of 0. So we can use remainder theorem or synthetic division. Now remember, we're lucky. We have our calculator. So you could plug that equation technically into your calculator and look for an x-intercept. So I'm going to try x equals 1. Because remember, I, for synthetic division, use the roots. So on top, I write x minus 1. So I remember that that is the factor. So I'm pulling the roots right off of my table of values, and I'm using that number in my synthetic division. So can I count down? I need to remember placeholders. 4, 3, 2, 1, and none. So I can count down, so I just put the coefficients. I don't need any placeholders. 1, -2, -9, 2, and 8. And remember, when you have an x to the 4, you're going to have to do synthetic division to get to x to the 3, synthetic division to get to x to the 2, and then factoring. So the larger the degree, the more synthetic divisions you're going to have to do. So what do? I drop the 1. Change my color. Drop the 1. And then I multiply. 1 times 1 is 1. I bring it up here and I add. -2 and 1 is -1. And then I multiply again. 1 times -1 is -1. And then I add. -9, -1 is -10. And then I multiply. 1 times -10 is -10. And then I add. 2 times -10 is -8. And then I multiply. I'm getting happy because I see this can work. 1 times -8 is -8, and then I add, and it's 0, and I box that, and the remainder is 0. And if the remainder is 0, then I know that x minus 1 is a factor, and I know I picked a good one. Okay? Now, every single time you do synthetic division, it knocks it down a degree. So it was an x to the 4. This is now 1x cubed minus 1x squared minus 10x minus 8. And if I couldn't break this down by synthetic division, then my factors would be x minus 1, bracket, x cubed minus x squared minus 10x minus 8. I would just be done. But I can break it down, so I'm going to do another synthetic division. Except now I have coefficients of 1 for the x cubed, -1, -10, and -8. And I'm going to type that into my calculator into y equals. And I'm going to look for an x-intercept. So I get -2. So my factor is x plus 2. And I'm going to put these in red. So I remember at the end, I need these. Those are my, ooh, that kind of covered that one up. It's x plus 2. I'll go back over it. Okay, those are my factors I have right now, x minus 1 and x plus 2. And at the maximum, I'm going to have 4 factors because I can have at most the same amount of factors as the degree. The degree is 4 of the original question. Drop the 1, multiply -2 times 1 is -2, add -3, multiply -2 and -3, +6, add -4, -2, -4, +8. I'm happy because I'm getting a 0, so I picked the correct one. And the last one was an x cubed, so this one's going to be 1x squared minus 3x minus 4. And I can go right to factoring because it's a quadratic. So x squared minus 3x minus 4, what multiplies to give me -4 and adds to give me -3, give me -4, +1. And so I'm going to get x minus 4, x plus 1. And I can go right to x minus 4 and x plus 1 because there's a 1 in front of the x squared. I do not have to do decomp. But if there was not a 1 in front of there, I would have to do decomp. So these are not just my factors. So some people list these and say, I'm done. But remember, you have 2 other ones that I have in red circled. So actually, this polynomial, if I want to write it in factored form, is p of x equals x minus 1, x plus 2, x minus 4, and x plus 1. And I'm done. It didn't tell me to solve. I do not want x equals something. That's solving. I didn't ask you to solve. Okay? The next one says the volume of a bar of gold is 3x cubed plus 23x squared plus 45x plus 25 centimeters cubed. Determine the length, width, and height. They literally just want you to factor it. Get the three factors because that would be the length, width, and the height. Okay? So x equals -5 when I plugged the equation into my y equals and looked to my table. X equals -5 is an x-intercept. So my factor is x plus 5. Okay, so we're going to use our coefficients, make sure we can count down. 3, 2, 1, 0. If we couldn't, we need a placeholder. So we're going to get 3, 23, 45, 25. Drop the 3. -5 times 3 is -15. Add that is 8. Multiply is -40. Add that is 5. -5 and positive 5 is -25, and I'm happy. I get a 0. And because it was an x cubed, this will drop down to x squared. It always drops the degree. 3x squared plus 8x plus 5. I'm going to take that off to the side, and I'm going to factor it. I have to do decomposition because I do not have a 1 in front of the x squared. So I say to myself, what times what equals the first times the last, so 15. And what plus what equals 8. And it's going to be 3 and 5. And I replace the 8x with 3x and 5x because that is 8x. So I have to do decomposition. I can't go right to brackets or I'll be wrong. If you put x plus 3, x plus 5, you are wrong. So you have to do decomp. So we get 3x squared plus 3x plus 5x. If you put them in the other order, it would still work. But these ones go much nicer with the last term. So 3 and 5. I put the 3x first, it goes perfect with the 3. 5x second, it goes perfectly with the end 5 group. And I can take a 3x out. And I'm left with x plus 1. And then I can take out a 5, and I'm left with x plus 1, which is good because I need the same thing in brackets. And I get 3x plus 5, and I get x plus 1. And I do not want to solve them. I want to leave them as factors because it wants the length, the width, and the height. Okay? So our three factors for the volume here, our three factors are x plus 5, 3x plus 5, and x plus 1. And they want the length, the width, and the height. Well, we have to fill in what we know. We know x equals 5, so we can fill that in. So we're going to get 5 plus 5, which is 10. I'm going to write 25. Oops, 10. We get 3 times 5 plus 5, which is 15 plus 5. So that is 20. And then we get 5 plus 1, which is 6. So our dimensions, because it's centimeters cubed, are 10 centimeters by 20 centimeters by 6 centimeters. And if we want to figure out the volume, we could, if they asked us for the volume, we could actually figure it out. It would be 10 times 20 times 6. So our volume would actually be 1,200 centimeters cubed. Okay? We're going to look at this last one. I picked this last one in particular because it is actually missing the constant. Now, what some people do is they put a 0 back there, they plug it into their calculator, and they can't find an x-intercept, and they freak out. That's not what we do. If we're missing an x cubed, or we're missing an x squared, or we're missing an x, we put a 0 placeholder. If we are missing the constant, the very first thing we are going to do is factor out an x so that we get a constant. Okay, this one happens all the time and people get stuck because they add a 0 and they say, Mrs. Lepp, I can't find an x-intercept that works. So we're going to take an x out, and we're going to be left with 8x cubed minus 12x squared plus 6x minus 1. And now we already have a factor. One of our factors is x. Don't forget about that one. Okay? And then we're going to do synthetic division with the other one. When you plug the 8x cubed minus 12x squared plus 6x minus 1 into your calculator, you don't get any nice factors. So this is actually factored. They wanted this one in factored form. Okay? Because it doesn't give you any nice roots. Our last thing we need to go through is solving polynomial equations and graphing. or coming up with equations from graphing. So if they want us to solve a polynomial equation, they want us to go that one extra step. Factor means leave it in those factors. Solve means I want x equals something. So I'm still going to do the same thing. I'm going to, I could check my possible zeros of 1 and -1 because that's the constant at the back. But I'm going to plug it into my calculator into my y equals. And I'm going to go to my table of values and I'm going to pull off an x-intercept. And this is supposed to be a positive 9x squared, sorry. Okay, so 2x cubed plus 9x squared plus 6x minus 1. When you plug that into your calculator, you get an x-intercept of -1. So we get x equals -1. We don't actually have to list the factor above it because I don't care what the factors are. I want to solve it. I want x equals. So this is one of my zeros, my roots. Solve. So if it asks you to find the zeros, if it asks you to find the roots, if it asks you to solve, if it asks you to find the x-intercepts, that all means the same thing. Find what x equals when y equals 0. In this case, y equals 0. So we're going to put in our coefficients. Can we count down? 3, 2, 1, 0. We can. So we get 2, 9, 6, -1. Drop the 2. 2 times -1 is -2. Add it is 7. -1 plus 7 is -7. Add it is -1. And -1 is +1. And we get 0 and we're happy. So now we have 2x squared plus 7x minus 1. And I try and factor it. And I say, what times what gets me -2? And what plus what gets me 7? There's nothing. If this was factored, if I asked you to factor it instead of solve, your answer would be x plus 1, because that would be the factor to x equals -1. And you'd have 2x squared plus 7x minus 1. And you would be done if I said factor. But I didn't say factor. I said solve. So the only way I can get the answer to that, and if you plug it into your calculator and get the zeros that way, you are not doing it algebraically. And secondly, you're not going to get exact values. I need to plug it into the quadratic formula. So this is my A, this is my B, and this is my C. So I'm going to get x equals -b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So I get x equals -7 plus or minus the square root of 49 plus 8 over 4. So I get x equals -7 plus or minus the square root of 57 over 4. And 57 can't reduce into any perfect squares because 57 is prime. So we are done. But we also have to put behind this -1. So those are my 3x intercepts. The next one says determine the zeros. If you want the zeros, you have to get it equal to 0. So we have h cubed plus 0h squared minus 27h plus 10, and it has to equal 0. If it doesn't equal 0, you have to have it equal to 0. There is no h squared, so I have to put a 0 as a place. And 5 works. So I'm going to take x equals 5, and I'm going to go 1, 0, -27, 10. Drop the 1. 1 times 5 is 5. Add it is 5. 5 times 5 is 25. Add it is -2. 5 times -2 is -10, which is 0. And so I have x squared plus 5x minus 2. I cannot factor that. I'm going to circle this. I might even go so far as going x equals 5 down here so I don't forget to write it as one of my x-intercepts. I have to use the quadratic formula again because I can't factor this. So that's my A, that's my B, that's my C. So I'm going to get x equals -5 plus or minus the square root of 5 squared minus 4 times 1 times -2 all over 2 times 1. So I get x equals negative 5 plus or minus the square root of 25 plus 8 all over 2. X equals negative 5 plus or minus the square root of 33 over 2. And 33 I can't break down. It's as low as it goes. If you can break it down, say it was square root of 24. Just an aside, this is not it. Don't think it's part of the question or ask why it's showing up. If you have 2 plus or minus the square root of 24 over 2, pretend it's a totally separate question, has nothing to do with this question, okay? You could break the 24 down into 4 and 6. You'd get 2 plus or minus 2 root 6 over 2. And if you can take a number out of all 3 of these, you can. You can only take it out of 2, you can't. And the catch here is this is a plus 1 here, right? So it has to stay. This plus 1 in front of the radical can go away because you don't really need it. And the plus 1 in the denominator can go away. But this plus 1 here in the front has to stay. So I would have 1 plus or minus root 6. Okay? Now if you're wondering what this has anything to do with the question, it doesn't. I'm just showing it to you just in case you can reduce because both of these couldn't. So my answer to this question is x equals negative 5 plus or minus square root 33 over 2 and 5. Okay? Last page. Determine the equation of a polynomial function from words or a graph. So what you have to remember is to solve for that a value at the front of the polynomial. That's where everyone falters. They forget to solve for that a value. So this one says determine the equation of least degree for a quartic function. Funny that I put for quartic function. I don't know why I have that if it says least degree and quartic. It should be determine the equation for a quartic function with a negative leading coefficient. So my a value is going to be negative. Zeros, so x equals negative 2 multiplicity 2. Means my factor is going to be squared. And x equals 3 multiplicity 2. And a constant term. So when I said is a factor, you should think remainder 0. When they say constant term, you should think y-intercept, right? So that means 0 and negative 6 is a coordinate, an x and a y coordinate. So when we're coming up with polynomials, the equation, we're going to go y equals a. We need to find that a, that constant, or that coefficient in the front. That coefficient in the front is what changes your equation to get your y-intercept correctly. Your x-intercepts will stay the same no matter what that a is, but it will change your y-intercept because it's the stretch factor. So it's the vertical stretch factor, so it doesn't affect the x-intercepts because that's when y equals 0. So we need to put that a, we need to remember that a, and that's what everyone forgets is the a. So then we have a factor of x plus 2 because it was x equals negative 2. Multiplicity 2, so it's squared. And we have x equals 3, so we're going to have x minus 3 squared as well. Multiplicity 2. Okay, and then we're going to use our coordinate, our x and our y, and solve for our a every single time. It's not a hard question. You just have to remember the a. So we get negative 6 equals a. 0 plus 2 squared. 0 minus 3 squared. Negative 6 equals a. 0 plus 2 is 2, squared is 4, and these are multiplied. Negative 3 squared is 9, and it's multiplied. So I get negative 6 equals a times 36, because they're always multiplied, because they're factors, so they multiply by each other. Divide by 36, and I get a equals negative 1/6. And now I can rewrite the equation, because I still don't have the equation, I just have the a value now. So I need to rewrite it with the a value in. So I'm going to get y equals negative 1/6, which is helpful because it says negative leading coefficient. And we found that, so great. X plus 2 squared, x minus 3. So once you find that a, your work isn't done. You have to rewrite the equation. Now, coming up with an equation from a graph, we just need to pull the information that they gave us above off of this graph, right? So we have an x-intercept at x equals negative 3, smallest degree here. This one should be the smallest degree equation, because this could be x equals 3 multiplicity 2, 4, 6, 8, 10. It could be super different amounts. And if we want to get the same equation, we have to say least possible degree or smallest degree. So this one's going to be a multiplicity of 2 because it is tangent. It hits it and bounces back up. We have x equals -1. And there's only one going through it because it goes straight through. And then we have x equals 4, multiplicity 3, or 5, or 7, or 9. So that's why we have to ask for the smallest degree, because it makes this point of inflection through it, this little inflection, this little S-curve. So there's 3 there. Now, this graph needs to be an even degree. Why does it need to be an even degree when we look at it at the end? Because the arrows are in the same direction. And that also means I have a positive leading coefficient because it ends up on the right. So those are all hints to tell me if when I'm done in the end, I'm actually correct. And I can take the y-intercept off. If they give you another coordinate on the graph that's bolded, they're asking you to use that. So we have a y-intercept, so 0 and -120. So let's go and make an equation. So we're going to have y equals a. We also have to put that a. And then we're going to have x plus 3 squared. And then we're going to have x plus 1 to the 1, technically, or nothing. And then we're going to have x minus 4 cubed. And then we're going to plug in 0 and -120. So we get -120 equals a. 0 plus 3 squared. 0 plus 1. 0 minus 4 cubed. I get -120 equals a. 3 squared is 9 times 1 times 4 cubed, which is 64. And then we're going to have to multiply those. So we have 64 times 9. So we get -120 equals a times 576. Divide by 576. And you get -5/24. Something is awry. Oh, this is negative. I was like, I know I need to have a positive a because I have a positive leading coefficient. -4 cubed is -64. So this is -576. So this makes this actually be positive. See, it's important to know what your graph does because I caught my mistake. I knew that my a, my leading coefficient, needed to be positive because it ended up on the right. So I knew something was wrong. Okay, I'm not done because I haven't rewrote my equation. So I have y equals 5/24 x plus 3 squared x plus 1 x minus 4 cubed. And I'm done. And that's polynomials, everything we learned.